What's up, guys? It's Carter here. Today's lab is a little different than past ones because we don't know which chemical reaction is actually occurring. When iron solid reacts with copper 2 sulfate, the products are copper solid and an iron sulfate. But there are two types of iron sulfates possible here. Option number 1 is iron 2 sulfate FeSO4. In this reaction, the Fe goes to Fe2+, while the copper 2+ ion goes to Cu. This is called a redox reaction. You can see that FeSO4 is iron 2 because when you split the molecule, the Fe ion needs to have a 2+ charge to balance out the 2- charge of SO4 2-. Reaction number 2, our other possibility, forms iron 3 sulfate, Fe2SO43. Here, iron solid becomes Fe3+, and copper 2+ becomes copper solid. Once again, you can see that Fe2SO43 is iron 3 sulfate by looking at the charges of the two ions. Our job today is to figure out which iron sulfate is formed by using stoichiometry. In the first part of the lab, we're going to get the reaction ready and do it. And in part 2, we're going to get the copper product by itself so we can take an accurate measurement of its mass. So alright, let's get started. Our first step is to find the mass of an empty beaker. So grab an empty beaker as well as a container of iron filings and head over to the balance. Make sure to bring a scoopula too. Place the empty beaker on the scale and record the mass displayed. Then tare the scale and add about 0.3 grams of iron filings to the beaker using the scoopula. Be careful here, it's really easy to add way too much. If that happens, don't worry. Just pour the extra iron onto a sheet of paper and offer them to another group. Don't put the extras back in the original container though. That could contaminate the sample. Also, if you spill any iron filings on the scale, just use a brush to wipe them off the scale so they don't mess up your measurements. Now that you've recorded the mass of the iron filings added, it's time to head over to the bench. In a separate small beaker, add about 15 milliliters of 1 molar CuSO4. You don't need to record the exact volume here since copper sulfate is our excess reagent. Once you've added your CuSO4, remember to return the container to the cart. Next, we're going to use a Bunsen burner to heat up the copper sulfate. Turn on the gas, use the striker to light it, and begin heating the copper sulfate solution. Heat until you see bubbles coming from the solution. That tells us it's starting to boil. Turn off the gas, put on a glove, and take the beaker off the burner. Don't forget that glove. The beaker is still really hot. Still using your glove, carefully add the copper sulfate solution to the beaker containing the iron filings. Our reaction between the iron and the copper sulfate is now beginning. Now it's time for part 2. Our job is to get the copper solid by itself so we can measure its mass. A few minutes after starting the reaction, decant into an empty beaker. Decant is just a fancy way to say pour the liquid out carefully so that you leave all the solid behind. You can decant into the leftover beaker that you heated the copper sulfate in. You won't be able to get rid of all the liquid for now, so do what you can. Dispose of the decanted liquid by pouring it into the container labeled CuSO4 waste. Use distilled water to rinse the sides of the beaker too. No matter how well you decant, we still have one problem. The copper is still wet. The extra liquid would make the mass of the copper seem higher than it actually is. To solve this problem, we're going to head over to the hood to use acetone and a hot plate to heat up the copper so it is completely dry. We're using acetone first because it has a low boiling point. Notice if we squirt a little on the surface, it evaporates right away. When we later put the beaker on the hot plate, the liquid acetone will be sure to evaporate. Secondly, when we later decant the acetone, it will also remove the water because acetone is soluble in water. So squirt some acetone into the beaker with our solid and then decant it. To finish drying the solid, place it on a hot plate. Your teacher will have set the hot plate to the proper heat settings, so you don't need to worry about turning any one of those dials. Heat the beaker for about 5 minutes to make sure your copper solid is completely dry. While the beaker is heating, we can use this time to start cleaning up. Dispose the beaker with the decanted acetone in the container labeled non-halogenated organic waste. You can also tidy up your bench by using a paper towel to wipe it down. After 5 minutes, your copper should be dry. Remove the beaker from the hot plate. Don't worry, you can use your hands. The top of the beaker isn't that hot. And using the balance, find the mass of the beaker with the dry solid copper product. Great job with this lab. Dispose of the copper solid in the container labeled CU waste. Use a scupula to scrape all the copper out. Now let's head back to the classroom. Good luck, guys.